Hey everyone, welcome back to the Whiteboard app series. In today's video, we are taking things to the next level and implementing dependency injection with Koin. Plus, I will give you a brief overview of clean architecture. By the end, you will have a fully functional database integrated into our Whiteboard app. And remember, if this video hits 50 likes or 50 comments, I will drop the next part of this series. So let's dive in. Now let's take an understanding on clean architecture. Clean architecture is a software design philosophy that aims to create scalable, maintainable and testable code. It separates an application's code into distinct layers, each with specific responsibility, making the code easier to understand, maintain and test. In clean architecture, we divide our whole code base into three layers. Presentation layer, it handles the UI and user interaction. Domain layer, it contains the business logic and rules. It's the core part of the application and is dependent of any other layer. Data layer, it manages data sources and handles data operations. And here in our project we can see we already have divided our whole code base into these three layers: data, domain, presentation. Now let's see what each layer contains. First we have presentation layer. It contains composables where we define the UI and handle user interactions. View model where we keep the UI state and manage user interaction. Navigation where we handle navigation between different screens. And we can see in our presentation package we are keeping our composable function and the view models. And in the future videos we will also add the navigation to our application. And all that navigation code we will keep in this presentation layer. Next we have this domain layer. Here we keep the models that represents the business objects, repository interfaces where we define the function for accessing data, providing an abstraction between domain layer and data layer, and use cases. And in our project we can see we have this domain package, and here we are keeping our models, and let's also define our repository. So first repository we will have related to this path, and this will be of type interface. And the functions of this path repository will have the same functions we have specified in that DAO. So we can use this code, and for now we are using this path entity, but ideally we need to use the object we have specified in our domain package, but we will do this later in the video. For now let's just use this path entity, and here import this flow from the coroutine. And next layer we have the data layer. Here we define the remote data source where we manages network requests, local data source where we manage local database operations, repositories implementation where we provide concrete methods for data operations, mappers where we convert data between different layers. And we have a data layer, and in this data layer we have this local package where we are managing the local database. And here let's also define a repository, and here we will create a path repository implementation, and this will be of type class, and we will extend our path repository interface and implement our functions by pressing Ctrl I. And here we will provide the database, and we will get the path DAO from that database, and we can attach our functions from the path DAO. And this is how our data will flow. First we have this path DAO This DAO will help us in retrieving and saving the data into the database. And this path DAO we are using in our path repository implementation. Here we are simply connecting all those functions with the DAO functions. And these functions we will use in our presentation layer. So in our view model, we will get those data. So let's use this path repository. And in our view model, we use the path repository interface, not the implementation directly. Because here in the interface, we have not defined the actual implementation of this function. But the actual implementation we have in this here the benefit is, suppose in future we want to save the data into some remote database, not the local database. So we can simply just provide a different implementation of this path repository interface, and this view model will not be affected. And here in our view model, let's create one more function with the name insert path, and let's provide the path entity to this function. And again this path entity we are using from the data package, but in our presentation package we need to only use the data models we have specified in the domain package, but this thing we will correct later in this video. And here we can simply use this view model scope dot launch, and we can call our path repository dot upsert path, and we can provide the path entity. And this function we will call on this finish drawing. And here in this finish drawing, before updating the state, let's just call the insert path function, and we can provide these two values from our state. Now if we try to run our app, then it will give us the errors, because first thing, this view model object we are creating in that app function, but to this view model we are also passing the path repository object from the outside, and here we have not specified how that object will be created. And next thing, in our path repository implementation, we are also passing the app database from the outside. And again, we need to specify how this app database object will be provided to this path repository implementation class. So here we have two options. One, we can create all these objects and we will provide these object to this class manually. And next thing, we have a Koin library. That Koin library will help us in creating all these objects, and that will do all the hard work. We will just need to specify few things to that coin. So first thing here, let's create one more package with the name di for dependency injection. Let's create a file with the name init_coin for initializing the coin. And let's create a function with the same name init_coin. Since we are using the coin library, then we need to initialize that coin library. So that coin library will know that it needs to do some work. For that, here we have this function start coin, and we can see this is coming from that coin library. And here we need to define all the modules and any configuration, and the configuration we will provide wherever we will use this init coin function. So let's use this config, and configuration we will have this coin app declaration, and by default we will use the null. And first thing, we will use this config and invoke with this. Now let's use this function to both the platforms, and we have this desktop main and this main.kt file. Here is the entry point of this desktop application. So let's define this function differently like this. And before starting the application, let's initialize our coin. And we will not use any configuration to this init coin function. And the same thing we need to do in our Android platform. So let's open our Android main and this Kotlin package. Here we have this main activity, but we need the application class. So let's create one more class with the name my application. And let's extend this with this application class. So Android should know that this is the application class. And let's use our onCreate function here, and on this onCreate we can use our init coin function, and here we need to define some configurations. And first thing we need to define this Android logger, and next this Android context, and the context we will get from this application class. And why we are providing some configuration to this Android platform, not on this desktop? This is because this Android platform needs the context for creating some objects. And here we are specifying to that coin that if you need context anywhere in the application, you can take the context from here. And this application class we also need to register in that Android manifest file and close it. Now we have initialized the coin to both of our platform. Now we can close these files. And next thing, in our DI package, let's create one more file with the name platform module. And in our path repository, we can see we are providing the object of this database from outside. So here we need to define the object of this database to the coin, how it needs to create. But this database object will be created differently on different platforms. That's why we have this platform module, and we can use this expect function here. Let's use this platform module, and we will extend this with this module from the Koin. Press Alt Enter, add missing actual declaration, and we need the declaration for both the desktop and Android. And this has created two more files. In our Android main, we have this DI package in the same structure, and we have this platform module file. And here we can directly use the module, and we need to specify how that coin needs to create the object of the room database. And for that we have this single function, and here we can use that function get room database, and this functions need the context, and we can simply use this get function. So here we are saying that for creating that database object, you need to use this get room database function, and with the help of this function, you need to create the object. And here in this function, we already have defined how it needs to create this app database. And this function will need the context, so we have specified the get function, and with this get function, Koin will look into its generated code and find the context object. And this context object we already have specified in that init block. And this is how it gets the context. Same thing we need to do in our desktop platform. Again, we need to use this module and simply use this single, and here we need to use that get room database function. And on the desktop platform, we have this function, and this doesn't need any more objects. Now we can close these. Now we have the platform module. We can close it. And next thing, let's go to our view model, and here we are getting the path repository interface, but there is a implementation of this repository interface. So we need to tell the Koin that whenever we need the object of this path repository interface, then you need to bind the interface to its implementation, and from that implementation we can get the data to the view model. And this thing we will define in another file with the name repository module. Let's create a file, and here we don't need to use any expect function because we only have one interface in our common package, not differently in the separate platform. So here we need to use this val repository module, and again we need to use this module block, and we have this function single of, and here we need to say that we have a path repository implementation, but here this is not importing this path repository implementation, so let's import it outside. Now it has recognized, and we have this bind function on this, and we can bind this to our path repository interface. And this is how the Koin will bind that interface to its implementation. And everywhere we are using this single. So this represents that Koin will create only one object, and it will use that object throughout the application. It will not create multiple objects. Hey everyone, if you are finding this tutorial helpful, you will love my premium Udemy course where we will build Measuremate, a fitness app using Jetpack Compose. We go in depth on the Firebase authentication, Firestore, and more. Check out the course in the description and take your skills to the next level. See you there. Now next thing, this view model we are using in our app file here with the help of this view model compose, and this was good only when there was no constructor to this view model. Now we have a constructor, so here we cannot simply create the object of this view model like this. Rather we will use Koin to create the object. So again in our DI, let's create one more file with the name view model module. And again we need to use this module block, and we have this view model of, and we need the object of whiteboard view model. And again this is not importing, so first let's import it outside. Now we can use, and we have these three modules: view model, repository, and this platform. So here we need to specify these modules in this modules function. First we have this view model module, and next we have the repository module, and after this we also have a platform module. And last thing, in our app file we will get the view model with this Koin view model and import it. And right now we can remove this import. So this was all the code for that Koin library. Now let's run our app, and it has started this main activity, but let's close it and run our Android app. So here is the app. Let me draw something and open the database. For that, here go to this more tool and we have the app inspection. And here is the database inspector. But for some reason, this database always show the closed on this Compose multi-platform project. But on the Android project, it was working fine. But we have one solution. Let's close the app and it will download the data into the offline mode. And we can see here is our whiteboard database and we have two tables, one for this room master table and next we have this path table, and we can open it and we have some data. Right now we only have two things. First, this ID, this is auto generated by the room library itself. Next we have this drawing tool and we also have this starting offset saving into this database. So this is how the room database will work.